Hi everyone, my name is Sanya Laha, and today I'm going to explain you a small but important topic in algebra, that is linear programming. So before going into the depth of this topic, I would like to shed some light on its definition and why do we even need it. So basically, linear programming is a technical in algebra which helps to achieve the best outcome in a form of maximum or minimum kind of answers of any given mathematical problem. So it takes helps of the linear relationships or linear equation to find optimal value of the given function, and that is why it is also called linear optimization. So as the name suggests, this this is a kind of optimization technique which we can use in to solve any real life problems, especially industries like transportation, energy, manufacturing have proven usefulness of this kind of technique for solving the problems of planning, routing, scheduling, assignment, and design. If I give you a simple example, suppose you have 5,000 rupees in your hand for shopping and anything you can buy within this amount. So what will be your end goal? You will try to maximize the number of items you can purchase using this amount, right? So this is also an optimization problem. Here, the objective or the objective function will be to maximize the number of items you can purchase, and the constraints will be the amount you have in your hand, that is only 5,000 rupees. So here you have to remember that linear programming will always work under some given constraints. It's not that you can uh, achieve the optimal value, I mean, in account of everything. I mean, you cannot just randomly find any optimal value, but along with it you have to consider or you have to take care of the given constraints within the problem statement. So that is a big I mean, I should say the constraints play a big role in solving any linear programming problem. So next, the what are the components of linear programming? So there are basically four main components of linear programming, that is decision variables, objective function, constraints, and non-negativity restrictions. Now, decision variables, if you can see, I have given a simple formula of linear programming. So the decision variables are nothing but the independent variables which you can write in form of linear equation within the uh, objective function. So objective function most of the time denoted by z, and it is written in a form of linear equation as it is a part of linear programming. So it always uh, being considered that there will be linear relationship between the uh, end end result and the given uh, variables, I mean given decision variables or function. So objective function will be written as v equal to ax plus by in this form. There can be multiple decision variables or and their individual coefficients are also given within any kind of linear programming problem. Next, the important part of linear programming is constraints. So as I say, linear programming always work under some constraints. You cannot randomly find any optimal value of linear programming. I mean, if there is no kind of constraint given, then you can find any maximum value of the objective function or any minimum value of the objective function. So it has to work under some given constraints, and that is why it is called optimization. So constraints are mostly given in form of inequalities. You can see over the slide, I have written as px plus dy greater than equal to e, px plus qy less than equal to r. But sometimes you can also see constraint in form of equality. Next is non-negative restrictions or non-negative constraints. These are nothing but main characteristics of linear programming. You have to assume or consider that the independent variable or the decision variables will always be non-negative. Even if it is not given within the problem statement explicitly, you have to assume it. So yeah, these are all about the components of linear programming. Now, what is optimization? I think I have said enough about optimization, and you also know what does it mean by optimization. But to elaborate a bit, optimization is nothing but a process of finding best solution of any given problem by choosing the best decision among multiple set of alternatives. So, so in linear programming, our end goal will be finding the optimal value of the objective function by taking care of the given constraints. So most of the time we will try to find the maximum or minimum value of the objective function subject to the given constraints. And these constraints are nothing but the user preferences or any kind of restrictions which are naturally imposed by I mean, which are naturally imposed on the it's kind of a naturally imposed limitation which we can face in any real life case studies. So, by taking care of all these constraints, we have to optimize the objective function, and that is the goal of linear programming. I mean, solving any linear programming problem. If you want to know more about optimization, then you should uh, read about gradient descent. So what is gradient descent? It is nothing but a kind of optimization algorithm for finding the global minima of a differentiable function. And this gradient descent is hugely used in machine learning to find the value of function parameters, or you can say coefficients, that minimize a cost function as far as possible. Now, what is a cost function? Cost function or loss function is nothing but the difference between the true values and the estimated values which we find by building any machine learning model. So it basically find the cost function or loss function basically finds out the difference between the prediction and the true values of the target variable. And all our end goal for any machine learning problem will always be to reduce this difference between the true value and the predicted value, so that the model can deal with any kind of real life scenarios or any kind of unseen data in future. So that is why we have to take care of the optimization in machine learning, especially in supervised algorithms, from from a serious point of view. And gradient descent helps in this part. So gradient descent basically calculates the differentiation of a loss function with respect to the given features or parameters of the machine learning model, and tries to reduce the difference between the true value and the predicted value. And that is why it is also called optimization. Now, there are two types of optimization available. First is unconstrained optimization. and another is constraint optimization. So what is unconstrained optimization? As the name suggests, there will be no given constraints available within this kind of optimization problems. You will only get to see the objective function, and you have to optimize it without taking care of any restrictions or limitations. So uh, uh, if you want to know examples of unconstrained optimization, you can say linear or polynomial regression, ridge regression, logistic regression, neural networks are good examples of optimization. So for solving this kind of optimization, we take help of methods like iterative methods or analytical solution using multivariate calculation. So what is iterative method? It's nothing but the solution technique like gradient descent. So in gradient descent, what we do, first try, we first start with initial value of the given, I mean, we first try with, start with the initial solution of the given function, and then tries to converge to a better solution through performing the same step again and again. I mean, first we try to find the differentiation of the loss function with respect to a parameter, and when we then see that what kind of improvement we get to see within the loss function, whether the value is reduced or not for that particular I mean, point which we get after the differentiation. And then again, if it is not much improved, we try to converge towards the global minima. I mean, by finding the local minima by by the repetitive differentiation, we reaches towards or converges towards the global minima. And that is why it is called iterative method, which means we need to perform the same steps again and again. And what is analytical solution? It is nothing but we directly evaluate the first and second and ordered conditions, and then find the optimal value of the parameters. I mean, we will not, perform the steps again and again. We try to evaluate it in at one go. Now, constraint optimization. So it is nothing but there will be objective function as well as the constraints. In linear programming, it is a constraint optimization problem because you will see the objective function and you have to optimize it under multiple given constraints. So linear programming is definitely a constraint optimization problem. Also, there are other examples like quadratic programming and SVM. So what are the solution techniques of constraint optimization? There are multiple techniques available like primal methods, penalty and barrier methods, dual and cutting plane methods, Lagrangian methods. So these are the different solution techniques available. So I'll not discuss in detail about this individual techniques. Maybe in some other video I can discuss about it. But for now, just keep those name of this just keep the name of these techniques in your mind, and let's move ahead. Now, what are the process of optimizing? I mean, for optimization, we need to follow some specific steps. In case of linear programming, I'm saying yes. So, what are those steps? Let's discuss. So, before solving any linear programming or linear optimization problem, you have to first identify and name the independent or the decision variables consistently. I have shown you that what are decision variables. Those are nothing but the independent variables available within a linear equation in form of objective function. So those you have to identify correctly by reading the problem statement or the business problem properly. So first you have to do that. next task is to mathematically define the objective function in terms of variables. So you have now identified that what are the number of decision variables available within the given problems. Are those one, I mean, there can be one, two, or multiple decision variables. And now your task will be to create an objective function by writing the but you have to write a linear equation by considering the decision variables and its coefficient, and then that will be defined as an objective function for your problem. The next step will be to identify the given constraints, means the restrictions or the limitations which are imposed by nature or user for your given problem. So those constraints you have to identify properly. You can see inequalities. I mean, most of the time, if you read any linear programming problem, you will get to know that you have to write constraint in form of inequalities, but there will also be equality constraints available. So first read the problem statements thoroughly, because you have to, I mean, segregate all these individual components before trying to solve the uh, mathematical calculations. So before getting into the calculations, try to name and identify those individual components of a linear programming. So once the decision variables, objective function, and constraints are identified, next step is to identify the hidden constraint or the non-negative constraints, which you have to assume by default. So these four components are now identified, and you have written those clearly as in the form of equations or variables. Next is to identify what kind of optimization is it. Is it an unconstrained optimization or a constraint optimization? You have to identify. If it's a linear programming problem, then definitely it will be a constraint optimization because you have identified the constraints already. So next, the so as per the optimization problem, unconstrained or constrained, you have to pick the solution method and then start solving it. So how does any constraint optimization look like? So if you see, first you will write an objective function in form of v equal to function of and decision variables like x1, x2, xn, any number of decision variables you can see. Then you have to write the constraints in form of equalities like g equal to x1, x2, x3, or up to xn is less than or greater than equal to b1. Similarly, other constraints are also available. So next, uh, you can write the non-negative constraint as well, like x1 greater than 0, x2 greater than 0, y greater than 0 in this form. And now your equations are ready and you can start solving the problem. You always have to keep in your mind that the objective function and the constraint will always be linear if you are solving a linear programming problem. But if you are solving a quadratic programming problem, then the objective function will be quadratic. However, constraint will be linear then as well. So these are some important, you should say, notes or pointers for solving any optimization problem. And you have to remember this. Now, in linear programming, I already mentioned that what all steps you need to do before getting into the solution. Objective function you have to write in form of a linear combination of decision variables, because in linear programming, it by default assume that the equations will be in form of linear relationships, and the constraints also, both equality or inequality will be linear. So in linear programming, always remember everything will be linear. Now, I have shown you a simple examples of solving any linear programming problem. So most of the time, people uh, try to solve any linear programming problem by using graphical method. And I also prefer the same because graph helps to find the solution in an easier manner, and you can just visualize that how it is being solved, or what is the optimal value of any objective function, and you will easily get to see it within the graph. So try to take help of graphical methods for solving linear programming. However, there are other methods available. You can search over the internet that what are different solution techniques for any linear programming method. So you will get a hell lot of ideas or different techniques, so you can go for them as per your choice, but for now I am explaining you the graphical method of solution. So here our problem is to maximize the objective function, that is v equal to 2x plus 3y under the given constraints as x plus y less than equal to 30, x less than equal to 20, y less than equal to 12, and the non-negative constraints such as x or y greater than equal to 0. So here our objective function is v equal to 2x plus 3y. Here x and y are the decision variables, as you can clearly understand, and the constraints are like x plus y less than equal to 30, x greater than equal to 20, y greater than equal to 12, x plus y greater than equal to 0. So these are the constraints. Now in graphical method, you need not to do much hassle. You just need to identify the corner points first for plotting the graph. Now, what are corner points? Corner points are nothing but the intersection point, you can say, between the different lines which you can uh, plot by considering the inequalities uh, in form of equation. So to simplify it, here you can see the inequality such as x plus y equal to 30. So first you have to draw the lines, right? Or draw the draw the lines in form of within the graph. I mean, here the inequality, to draw any kind of line, you have to consider this as equation. So forget the inequality sign and just consider this as a simple equation like x plus y equal to 30, and then draw this line. If you consider this equal to 30, it will cut at 2 points. For 0 equal to 30, it will get this point, and for 30 equal to 0, it will get this point. So this is the line for the first inequality constraint. Similarly, for other two constraints such as x less than equal to 20, y less than equal to 12, if we consider those as equations, then we will get two parallel lines, one parallel to x, another parallel to y. So you are now done with plotting the constraints. So here you can see the points are, I mean, those lines are intersecting with the axis or the other lines at some points. So here the bold out points such as 0, 12, 18, 12, 20, 10, 20, 20, 0, those are the corner points. Why? Because it is containing the feasible solution of the optimization. How? Now you are done with plotting the lines within the graph, and you have considered the inequalities as equations and plotted the lines properly. You have found out the corner points. Now your task will be to find the feasible area of solution. If you consider x plus y less than equal to 30 within this graph, how will you get to see which area will be falling under this inequality? I mean, within this inequality region. Definitely the area below this line, right? Because it is saying x plus y less than equal to 30. So if this line denotes x plus y equal to 30, then x plus y less than 30 will be the region below this line, right? So that is why for this line, this particular equation, the feasible area of solution will be below this line, correct? Next, for other two lines, x less than equal to 20, what will be the feasible area of solution? Definitely the area at the left of this line, because this is x equal to 20 line and less than 20 means this area. Similarly, for y less than 12, what will be the area of feasible solution? Just below this line, this portion. So now we have to consider the common area for all these three constraints, because that is the main goal of optimization. You cannot skip a single constraint and find the optimization. You have to consider all of the constraints and then find the optimal solution. So if you consider the common area of feasible solution from all these three lines, x plus y equal to 30, y equal to 12, x equal to 20, then you can identify this area which I have highlighted with the blue lines. This is the common area of feasible solution for this linear problem. This area, the optimal solution to maximize this function, this objective function will lie under this region. Try to understand it very clearly that here you can't just say that okay, this is the optimization, this is the optimal solution, these are also the optimal solution, these are no. You have to consider all three lines equally, all three constraints equally, and have to find the common area of solution which is lying under this area. What should I say? This is a pentagonal shape thing. So this are the corner points. So now remember this, corner points will always contain the feasible area of solution, and that is why it is called corner points. You will get, you will not get corner points beyond or outside the feasible area of solution. Any corner points will always hold the feasible area of solution, and from those corner points only you will find the optimal solution of the objective function. So now you have plotted the graph, you have found out the feasible area of solution for maximizing the objective function. So now the final step will be to calculate the maximum value of the objective function, right? That is our goal, to maximize the objective function. Now, at what point this function 2x plus 3y will have the maximum value? Now you can try to calculate the value of objective function at each of these corner points. If you calculate the value of objective function at 0 equal to 12, you will see it will become 0, x equal to 0, y equal to 12. So the value of b will be 36. Similarly, for 20 equal to 10, what will be the max value of z? X equal to 20, y equal to 0. So the value will be 40. So at this point, the value of objective function is 36. Here is 40. Now, at what will be at this point, 20, 10? put here as 20 and 10. You can see 2 plus 20, 40, 3 plus 10, 30. So 40 plus 30, 70. So Z will be 70 at this point. And what will be here at C? C, it is 18 and 12. If you put x equal to 18 and y equal to 12, it will be 36 plus 36, 72. So Z is 72 at this point, and this is the maximum value of objective function, and that you can calculate by finding out the corner points. So this is the entire process of solving any linear programming problem using graphical method. And when you are when you will be used to this kind of a solution, you can see that it will not take more than 2-3 minutes to solve this kind of problem. As I'm explaining this to you for the first time, you must feel that okay, this is a time taking process. No, this is not. Even from my point of view, I have tried other methods of solution, but I failed. And till now I feel that graphical method is the easiest one. So try to take help of graph for solving linear programming problem. So yeah, this is it about linear programming. I'll not say this is all, or I have explained you everything about it. There are so many uh, stuff I need to inform about linear programming. But for the beginning, I mean, if you are learning this topic for the first time, you can get a good overview of it and try to solve this kind of problems from internet. You will get a lot of example over there. So try to plot graphs, find out the corner points, solve the equations, and just find out the maximum value or minimum value of any objective function. So it will be quite easier for you to deal with, nothing to worry. So yeah, that's it from my side for today. Let me know if you feel any kind of doubts or any, uh, I mean, you feel that at some points I have gone wrong. So feel free to comment down below. And yeah, see you in next time. Thank you.